This video is all about a problem regarding vectors. Now let's read the problem. Using the component method, determine the resultant of the following vectors. So we have vector A with the force of 450 newtons and a direction of 30 degrees south of west. For B, with a force of 750 newtons due north. And for vector C, it has a force of 800 newtons and a direction of 50 degrees north of east. So if we're going to proceed with our solution, first provide a free body diagram. Okay? Now, after providing with a free body diagram, okay, we're going to proceed with the tabular solution. But for the free body diagram, for force A, since force A is 450 newtons, and then for vector A, it has a direction of 30 degrees south of west. So we're going to begin to plot this vector from west going 30 degrees to south. Okay, so from west, 30 degrees going to south. Okay, so this is our vector A. For vector B, 750 newtons due north. So it just points upwards. Okay, so this is 90 degrees. Okay, so this is force B, 750 newtons due north. For force C, 800 newtons, 50 degrees north of east. So we're going to start graphing this vector from east going 50 degrees towards our north. So as you can see here, this is already our vector C, 800 newtons, 50 degrees north of east. Now let's proceed. The second step for this solution is to provide a tabular data for the vectors, the summation of forces vertical, summation of forces horizontal, and then after that, we're going to determine now the resultant force and the resultant angle. Now let's proceed with the tabular solution. Okay? As you can see here, the first column is regarded as forces, the second column as horizontal forces, and the third column as vertical forces. Now let's proceed. For the first A or vector A, if we're going to bisect this graph and illustrate in details the forces or vectors for letter A, it has horizontal force pointing towards left or west and a vertical force that is southwards. Okay. So for AX, it is negative. For AY, it is also negative because if we're going to base our signage, it must be in a Cartesian plane mode. Okay. To determine now the horizontal force AX, so since this is an adjacent and we are already given with the hypotenuse A as 450 newtons, so cosine 30 degrees is equal to negative AX all over 450 newtons. And then if we're going to bring out AX here, we need to cross multiply 450 to cosine 30 and then multiply both sides of equation with negative 1. So AX now is equal to negative 450 newtons cosine 30 degrees. Now to determine now the vertical force AY, since this is already your opposite here, and we are already given with the hypotenuse at 450 newtons. So this is sine 30 degrees is equal to negative AY all over 450 newtons. So why is it negative? Again, it points downwards. Okay. If we're going to bring out AY, cross multiply 450 newtons to sine 30 degrees and multiply both sides of equation with negative 1, this becomes AY is equal to negative 450 newtons sine 30 degrees. Now let's proceed with vector B. So vector B has only a vertical force 750 newtons, which points upwards. It has no or zero horizontal force. So 0 for horizontal force, and its vertical component of force is 750 newtons. Now let's proceed with vector C. For vector C, as you can see here, it has a horizontal force pointing towards our right or east. So that is positive. And it has a vertical force pointing towards north. So that is also positive. Now for its horizontal force, so it is adjacent. So this becomes cosine 50 degrees is equal to Cx all over its hypotenuse, 800 newtons. So if we're going to bring out Cx, this becomes 800 newtons cosine 50 degrees. On the other hand, its vertical component, it is sine 50 degrees is equal to Cy all over 800 newtons. If we're going to bring out Cy, this becomes 800 newtons sine 50 degrees. Now, the next step we're going to do is to sum all the horizontal forces. So negative 450 newtons cosine 30 plus 0 plus 800 newtons cosine 50 degrees. This brings up to a value of summation of fx is equal to 124.5187 newtons. On the other hand, for the vertical forces, we're just going to sum all these forces as negative 450 newtons sine of 30 degrees plus 750 newtons plus 800 newtons sine 50 degrees brings up with the value as 1,137.8356 newtons. The next step to do is to determine now the resultant force. So to determine now the resultant force, since we are given with summation, since we have solved the summation of horizontal force or Fx is equal to 124.5187 newtons. On the other hand, the summation of vertical forces as 1,137.8356 newtons. For the resultant, we're going to use the Pythagorean theorem. As you can see here, our R resultant is the hypotenuse, and the summation of forces Fx points towards, again, the right, whereas our Fy points upwards. So to determine now our R, let's apply Pythagorean theorem. R is equal to the square root of f of x squared plus f of y squared. Now, substituting the values of the summation of f of x, okay? So this is 124.5187 newtons quantity squared plus the summation of vertical components at 1,137.8356 newtons quantity squared gives us a value of, now remember, this is inside a square root. So this is 1,144.6287 newtons. Now to determine now the resultant angle theta, okay, we're going to use tangent function. Okay, so tangent of our theta is equal to our opposite force, which is Fy or summation of Fy all over is adjacent at summation of f of x. To bring out theta is we need to use the inverse tangent function for both sides of equation. So this becomes theta is equal to inverse tangent or tangent raised to -1 of the function Fy all over Fx or summation of vertical forces or summation of f of y all over summation of horizontal forces f of x. Now, substituting the values gives us with our final answer for the resultant angle at 84 degrees.